Hi, everyone, and welcome. My name is Whitney Austin Gray, and I lead research at International Well Building Institute. And today we are speaking about good bugs versus bad bugs, the role of the microbiome in buildings. And we are joined by two of the leading global experts in this area. And I'm so excited about the topic. And so, with that, I'll have each one of them introduce themselves and speak a little bit about their research area. So, Dr. Claudia Gunsch, can you please kick us off?
Yeah, sure. Thanks, Whitney, for engaging with us on this conversation today. My name is Claudia Gunsch. I'm a professor of civil and environmental engineering at Duke University, and I also serve as the director for the National Science Foundation Engineering Research Center for Precision Microbiome Engineering. That's a mouthful, but we call it Premier in general. And this is a collaboration of 5 North Carolina institutions headquartered here at Duke, but we also have UNC Chapel Hill, the University of North Carolina at Charlotte, North Carolina A&T, and North Carolina State University. And the work that we will be talking about today is really important work. As a mother of 3 children and in a family that does have a couple of individuals that have been diagnosed with inflammatory modulated diseases, knowing that there is something that we can do and something that we can study, thinking about the microbes of all the spaces that we occupy, is a personal story for me that I really hold dear to my heart. So we'll be talking more about that today.
Thank you so much for that. And Dr. Anurodh Tripathi.
Thank you, Whitney. Yeah, so my name is Anurodh Tripathi. I go by Anu. I am the co-director for the innovation ecosystem in the same center, Premier, what Claudia talked about. So what that means is that we are trying to create a culture of innovation within the center where the work that is coming out of the center has some legs into the commercialization space. And we'll talk more about this into the conversation. My background is in chemical engineering, and I am an NC State graduate. My work was more on the bio bioeconomy side. So understanding how we can find a use of the materials that we get from plants. And somehow that work led me to chemical industry and now to Duke into this premier center where I am using my chemical engineering, some of my business development to support the center in the innovation ecosystem.
That's amazing. And I'll turn it over to Dr. Gunsch to speak a little bit more about this center. So, give us a little context with the National Science Foundation. This is a huge honor and what you're doing to lead this work. And would love for you also to share with us a little bit about the goals of the center and some of the topics that you are focused on doing research on.
Yeah, so NSF ERCs or engineering research centers are big, large centers that bring together researchers that have very different backgrounds. And so this is a unique opportunity to enable faculty with expertise in different areas to come together around an important problem with high societal impact. And so the work that we selected to work on is thinking about the microbes in the built environment and how humans interact with the built environment, and in turn, how the built environment impacts the microbes that are in those spaces. So the background for why we went after this particular work, I had done a study with a colleague of mine, Dr. Heather Stapleton, over in the Nicholas School of the Environment here at Duke. Dr. Stapleton focuses on measuring chemical contaminants that are in the environment. And we were really interested in developing a better understanding of associations between the contaminant profiles and microbes that are in our gut, so the human microbiome. And one of the findings that was really surprising when we looked at the signatures, the microbial signatures that were in children's guts, we found that there were organisms that are similar to the ones we use to detoxify hazardous waste sites. And so this really brought it back full circle for me. My expertise as a civil and environmental engineer is in bioremediation, where we utilize microbes to detoxify the environment. So I didn't expect that we would be finding those same microbes in the children's guts. In hindsight, it makes a lot of sense when you think about it. We're exposed to these chemicals, flame retardants, chlorinated compounds through the furniture, through our electronics, through a variety of different products that we come into contact with. And so our own microbiome has adapted to detoxify itself. And so this really got me, going down this engineering thought process of how do we interact with our built environment? How does the built environment then help shape our own microbiome? And that's really what Premier is all about.
Yeah, and what I just say to people when I introduce Premier, and it's a very high level introduction to what Claudia just mentioned, is there are so many products coming in the market which are probiotic for your gut health. It improves the gut health. What we are trying to understand that it's just not the bacteria in the gut that affects our health and our mood. It's also the bacteria and microbiome around us in the buildings that we live in our homes, workspaces, bathrooms, everywhere that we interact with. That also affect our health and our environment. So the center is trying to understand what are those good bugs you mentioned at the start of your talk. What are those good bugs? What are those bad bugs? And what is the right balance between each so that we get the beneficial microbes helping us for a better health. And hence the center is focused on identifying the technologies to do that and what are the technologies we can build to help us achieve that vision.
So, the topic of good bugs versus bad bugs is an oversimplified title, but too often we hear about this pathogenic model that focuses only on the bad bugs. This idea that if we use antimicrobials, right, or we try to detox, or if we buff the floors in hospitals that are super shiny and white, we'll get rid of the dirty, bad germs. And I want everyone to pause listening to this because this is actually, we can have sort of historic context for this feeling like if it's bright and white and shiny, it's clean, which is not accurate. The Hill-Burton era actually ushered in a series of hospital designs that we are still trying to recover from because it was based on this premise, without truly understanding germ theory, that our built environment should be bright, white, and shiny. So let's talk about good bugs and bad bugs and how it's so critical that we make a bridge to the built environment experts to really be able to design, operate, maintain the built environment with a better knowledge and feeling more empowered about how do we not just operate the building, but maintain the building and the people in it to be healthy. So let's just dig right into that topic. When I say good bugs versus bad bugs, Anu, do you want to start in helping kind of break down that first off, they're not separate. And, what is our message to help people better understand really their microbiome and what's so important about keeping our microbiome healthy?
Sure, yeah. And again, I'll start from a very high level and then I'll let Claudia to dig deeper into that. So as you mentioned, good bugs, bad bugs. As we are interacting, going out about our day, let's say we are gardening. There are so many microbes that we are exposed to. There are many good microbes within that, and there may be some pathogenic microbes there too. We go inside our homes, we bring all those microbes with us. Now, the question is, how do we balance it better? In the last few hundred years, with germ theory you mentioned, people have been hyper focused on the pathogens, that these pathogens, they are very harmful for us. Let's just kill them. And an approach has been disinfectants or other solution, just wipe it clean, make it shiny. That, of course, has helped us. The infectious disease deaths have come down rapidly. But at the same time, the cost is many of the microbes that were beneficial for our health, they have also become extinct. And it has been repeatedly shown that this may be the cause of some of the inflammatory diseases that we are seeing in our modern society. So the question is, again, what is a good bug? And the center is frankly trying to answer that. What is that good bug and bad bug? And how do we make a balance of that?
Yeah, thanks, Anu. I will add to that microbes are everywhere. They're ubiquitous. They are on all the surfaces that we touch. They are in the air that we breathe. They are in the water that we drink. And the vast majority of time, we come into contact with these and we don't get sick. But as Anu mentioned, right, the way that we often think about microbes is through the lens of that pathogen. We know those microbes that do make us sick. And so we go to great lengths to eradicate and get rid of all of the microbes that are present, really in an indiscriminate fashion. And so really, that's not the best solution. It maybe was at a time when we didn't understand that there were microbes that had these beneficial properties, but it now is clear that that is a problem. And to make matters even more complicated, we know that through some of these cleaning procedures that we use, not only are we removing some of the beneficial microbes that may be protective, we're also leading to these pathogens becoming even more pathogenic. And so we're really selecting for organisms that are even worse than their predecessors. And so that's really concerning, because in a day and age when we are running out of antibiotics, running out of solutions to cure against some of these dangerous pathogens, we need to really think about a more holistic solution.
Your work is so incredibly important, and thank you for everything you are doing. In particular, I think from a public health perspective, is that many people in this generation had no institutional memory of truly infectious diseases that were pandemic level. The closest was epidemic levels around HIV. So this generation was largely dealing with chronic diseases as the way that people die. And, within public health, we know that if we go back even 100+ years, that we live around 40 years longer than our great-great-great-great-grandmother. And the majority of the reason is not because of pharmaceutical intervention. It's because of environmental and occupational interventions. And so the power to bring better knowledge into this era where we have now come through COVID, and there really is too often a misunderstanding or an overwhelm in feeling like, how do we get rid of the bad bug? How do we get rid of the pathogen? How do I avoid COVID? Right? How do I avoid the flu? And the reality is it is present and it will be endemic moving forward. And so how do we build up and strengthen our microbiome is so critical. And the next question, I would love to do a speed round with you both on some very common terms or vernacular that we hear around the microbiome, where I think people don't really understand the full context of some of these terms. So when we talk about antibacterial or antimicrobial, what does that really mean? And I also really want to elevate this concept that when it's said anti, almost let's get rid of it, it's bad. It doesn't take into account that there are many good microbes, to Claudia's early point, that we really also need to be thoughtful of. So Claudia, do you want to help us sort of define some of these common terms?
Sure. So I think this is one of the more common terminology that is used. So antibacterial, antimicrobial is really products that will prevent the growth of a microbe. And often these are non-specific. So we can think of, for instance, nanosilver is an antimicrobial agent that has been incorporated into a variety of different consumer products. There is, for instance, socks that are made with with nanosilver, and the rationale for it was so that when you sweat, your socks don't smell as bad, and your feet don't smell as bad when you're sweating. So that's one example. We could think of a lot of other ones, microban that's put on surfaces to prevent microbes from growing. So those are some of those examples. Most of the time, these agents that are incorporated into consumer products or surfaces are indiscriminate. They are not targeting a particular microbe. So it's very similar to an antibiotic. If we know that we have a bacterial infection, we are prescribed an antibiotic. Usually that will be prescribed based off of the bacterium that we think we are infected with. So that it can target that class of microbes. But very often those antibiotics, again, they will target all of the microbes in that particular class. And so that's in terms of thinking about the parallel that more people are familiar with. That's how I would describe it.
And another example is in paints. So recently I was going to Lowe's and Home Depots to find a paint, and I saw there are antimicrobial paints available too on the shelf. And I was thinking, what does that actually mean? So and I understood that the marketing is that people are afraid of bugs. Now, COVID has highlighted that to a much more broader sense where people are afraid of bugs. And the solutions like paints, they try to alleviate that their sense of fear that if I have my building with antimicrobial paint, I will be okay. There won't be any bugs that will infect me. But the details, as Claudia was mentioning, that it may probably help in some of the pathogenic bugs. It may, we don't know. But at the same time, we will be getting rid of most of the beneficial microbes that we do want interacting with our body. So, yeah.
And there's so many powerful stories historically where we thought we were doing the right thing just to find out that it couldn't have been worse. So the stories of flame retardants, we actually found out years later, there was lots of fingers pointed towards experts that worked in furniture, for example, or we used certain even pajamas that we said children should wear, and we would put flame retardants, right, directly into these materials. In reality, the focus should have been smoking in the home that was causing this increased amount of burn issues. But in the interim, these interventions were put in. So we're putting flame retardants right on the skin of children through a dermal route of exposure, not to mention inhaling that. There's further examples. Many people might be familiar with DDT. So although malaria is not something that many people encounter in the US, many people don't realize that the CDC, the Centers for Disease Prevention and Control, of course, coming in the southern areas located outside of Atlanta, was an area that was strife with malaria. And so we used chemicals, right, to reduce DDT, but there's now byproducts of that, secondary generations that are still in our environment. And when you look at some of these campaigns, I mean, again, spraying the wallpaper of a child's room, and because people were so afraid of malaria, right? They were so afraid of my child getting burned. And so we use that, and then interventions are put forward without scientific review, without a better process for evaluating and regulatory process. And I think that what I remind people is this was not malintended, oftentimes we really were trying to look for a better intervention, but it had negative consequences. And so I would love for you to talk about some of the work that you're doing to make sure that we don't make those mistakes of the past. And I was very interested in what the center is doing to catalog, particularly within microbes, and to be able to communicate this out to our community. And also a little bit about the great work that we're doing in partnership to take this research with the hopes to translate this into specific, credits and terminology in the future to help our community better learn how to take what we know and be able to translate and better make decisions in the built environment around products, around processes, such as cleaning processes, operational strategies, and also just long-term how we even maintain buildings better. So we have a lot of great work to do together. Maybe Anu, do you want to start us off with speaking about some of the work you're doing at the center to really catalog and build better awareness for our population that says, okay, I know this is an issue. It's overwhelming. There's what we know, there's what we don't know. How do we start to catalog and help people better understand how we need to move forward so we don't make the mistakes of the past?
Right. You used a very right word, overwhelming. Yeah. So this problem statement is huge. And we acknowledge that it's such a big problem that we as a center, even though it's a center of 5 universities, cannot do it alone. So that's where we are partnering with other companies, nonprofit organizations, even centers or agencies like yourself, government regulatory agencies. So we are bringing all these people together and as part of our advisory panel in the center and discussing the work with them to understand if we are in the right direction. Now, the direction that I'm talking about, these are twofold. One is we want to build products that help society, that have commercial leg. And the second leg is of regulatory and of public perception. So we are trying to bridge both these two things together by trying to bring these regulatory agencies along with the industry partners to have the discussion on the same table to understand what are the regulatory things we should be talking about right now, so that the technologies that we are working on in this microbial space get to the final stage of commercialization and help people on the way. So that's one of the approach that we are taking. Now with IWBI, International Well Building Institute, we see ourselves as a center that brings expertise in the microbial side that can be used in the building standards through IWBI. And I can probably give you one example of the work that we are doing in the center. And Claudia can probably dig deeper into that too. So one of our use cases is on hospital-associated infections. And the source that we have found, one of the source is the P-trap underneath the sinks that harbors bacteria that become resistant. And the immunocompromised patients, they are more susceptible to those infections. So the center is trying to approach that problem statement through multiple pathways as to what can be done from the material perspective. Can we change the design of those P-traps? Can we change the material used for those designs? From the intervention side, what can be put into the system that gets rid of those pathogenic bacteria at the same time, keeping the beneficial microbes healthy. So that is one of the example that I would like to share from that perspective.
So adding on to what Anu just said, what's really interesting about microbes is it's really about the context in which they live. And so a microbe that may be bad in some instances may actually be good in others. And so one example that we can think of is, for instance, C. diff, Clostridium difficile, which is an organism that is affects has gastrointestinal effects that can be very, very severe and debilitating for immunocompromised individuals. About 3% of the population carries this microbe, and yet there isn't 3% of the population that's suffering from the consequences of C. diff. Another one is staph. So this is an organism that we often think about for MRSA, methicillin-resistant Staph aureus. And so again, we carry staph, and in some cases, some of the properties help fend off other organisms. So it's really about the balance in that microbial community that we need to better understand. And so most of when we think about the pathogens, we're usually only interested in quantifying those particular pathogens, but we don't look at it holistically. And so that's really what we are working towards, is can we develop some type of framework for developing a health index that encompasses not only the pathogens, but the pathogens within that broader context. For instance, is it the diversity of microbes that are in that environment that provides a resilience to that community to potentially selectively exclude or selectively silence some of the pathogenic features? And so those are really the driving motivations behind the work that we do. And the example that Anu just gave about the P-trap, we've chosen to focus on this because we know in hospitals that there's been a number of cases that stem from enrichment of these antibiotic-resistant microbes known as escapee pathogens in those particular spaces. They then grow. This is the perfect environment. It's moist. It has lots of nutrients. It's a very happy environment for these pathogens. And then ultimately, these can aerosolize, and there may be an immunocompromised patient in that room that then becomes infected. And so we're really trying to understand what is the balance. We know that those microbes are going to be there, but can we keep them in a place that is not going to cause harm to the individuals occupying those spaces?
Absolutely. And maybe I'll spend a couple minutes on some examples that you both have, because I think the stories are so powerful, really just in high touch surfaces and the work that we need to do in buildings to better reduce colonization of certain bacterial and microbes, and where we can there's simple design solutions. And so this really is a place I will elevate what the Well Building Standard is doing, and we will continue to advance this work. But for example, a very significant area of the building that does not receive enough attention is the bathroom space. And just looking at where these high touch interacting, moments are, where people are holding doorknobs, using faucets, where we see bioaerosols in this environment, and there could be better design. And so in particular, in our water concept within the Well Building Standard, we look to ensure bathroom accommodations. And so what you'll see is that we actually look to see that there's a bathroom that's hands-free. If there is a knob when you're leaving the bathroom, this seems simple, but it's not. Everyone else has touched that did or did not wash their hands, versus being able to push or use an elbow or to have a panel. It's a simple design solution, but too often we see it missed. We really want to look at the column, the sink column, and the dimensions of the sink, in particular where that column of water is going to go. We look at these sort of splash factors. This becomes very interesting in hospitals. So although this understanding and research has been applied in design in residential and corporate commercial, a lot of it started in emergency departments and burn units of hospitals, where when we have colonization of certain pathogens and bacteria, we have extremely, those that have really depressed immune systems that are more susceptible. We also learned about this with high touch surfaces within an emergency department that were not cleaned or washed. And the assumption is we'll teach the crew to better clean underneath the tables, right? Or we'll look at these high touch, moments, even using like phones, right? The reality is human behavior is such that the cleaning crews, it was difficult to train. It's difficult to anticipate that they're going to just understand how to use some of these chemicals best. So it's a big question for you, but I would love to hear some examples when we think about high touch in the built environment. Are there some innovations? Are there some design strategies that you're both, thinking about or even working with manufacturers or partners to just rethink, what are some of the ways that we've learned to use materials, products, or strategies better to try to reduce some of those issues in the built environment? Claudia, do you want to start?
Sure. So all of the examples that you share, really, these are the crux of what we are trying to study. I think one of the challenges when we look at this is, again, we really don't have a good catalog of the microbes that are even in our built environment. And so developing these types of strategies are very difficult to do because we have just a subset of that data. However, minimizing touching particular surfaces and ensuring that there is a way to get out of a bathroom or a building that doesn't require you to touch is definitely the way to go. There's also a movement that was championed, I can't remember from what organization, but to get rid of sinks altogether in hospital environments, right? So can we just really think outside of the box, and are there other ways that we can accomplish that same end goal? So that's great.
It's a very good point Claudia brought up, that we don't know what we don't know. So at this point, I mean, we know a very small subset of microbes, and we have a lot of information about the pathogenic versions of them, which are harmful for us. And hence the information that those high-touch surface areas, what are the designs we can do? Some of them, Whitney, you mentioned, to prevent us from touching those high-touch surface areas. Now, the center is going a little bit further into thinking that we know there are some good microbes. What are the technologies we can build so that we start categorizing those microbes in a more holistic fashion? And once we have a bank of those, think of like the seed bank. So once we have a microbial bank, we'll have much more power to generate better technologies that encourages a good balance of good and bad microbes. From the short-term perspective, we can think of, like, we are working with some of the partners on microbial cleaning products. So you can think of technologies like those. Some of them are actually on the market, on the shelf. We don't know how good or bad they are, but they are on the shelf with the claim that you apply them on the high-touch surface areas, and they will quote unquote clean the surfaces of the pathogenic microbes, but at the same time encourage the beneficial microbes. We don't know how good or bad they are, but they are still a direction where we see the market is going.
Yeah, and if I can add to that also, it's very likely that there are some solutions that are holistic that will work for most of the populations, but we also speculate that there is likely some solutions that are very precise for the individuals that occupy those spaces. We know that when an individual occupies a built environment, that their microbiome immediately takes over the microbiome in that particular space. And we know that in residential environments, that is very stable because there's less in and out of people in those particular spaces. And so we can think about how the humans in those spaces have adapted to that particular microbiome. And so there are likely some very precise alterations that we can make, and we're really just scratching the surface in terms of really understanding those particular associations.
Well, I want to close out today by speaking about next steps and partnerships. So, for all those that are listening to this, in summary, we're really at the beginning of understanding this space. It's really important that we partner and we take what we know in the research and we translate it into action so that we don't repeat some of the mistakes of the past where we react or respond to a disease by saying that we overly target the bad bug. Today it came up so many times in the conversation that so many of the products or technologies are non-specific in nature and that they maybe are even too toxic or not used correctly. And so we have these sort of malintended impacts where we actually really need to be supporting healthy microbiomes that are full of good and at times bad bugs, because that's part of sort of the complexity of many of these of understanding the human microbiome, right? And so this is the idea, even as a mother, when we think about our children, that we don't want them to never get sick, because then there's no resilience that they build in, right? And so there's just so much more information that needs to be given and shared. So if you're interested in learning more, this is the beginning of a conversation, the International Well Building Institute and Premier, and with our Duke experts on the line today. And I would love for you both to just close out with sharing with our community where they can learn more, what you're doing to host events and to educate the community if they'd like to get involved. Anu, would you like to start?
Sure, yeah. So we have our website, premier.org, where you can go and learn what the center is doing.
Yeah, and I can add to that. So we're really excited about this partnership with IWBI because you have been a leader in really thinking about how to be and how to operate those built environments in a sustainable and holistic way, which are shared goals that we have. There's a number of different ways to get information. The information, as Anu mentioned, is on our website. But we also are doing work in the community. So we're getting ready to launch a community citizen science project that is looking at more broadly the microbiome in residential sinks, so we can get a better understanding and again build this database of microbes and microbiome signatures that are present in our residential spaces. So look up our website, listen in on these conversations, drop us a line. We would love to hear from everybody in the community. And as we've mentioned many times today, it's a group effort and we don't have the answers to all of these challenges. And so, together we can put our heads to solve and study this important problem.
We are so honored to have Dr. Claudia Gunsch and Dr. Anurodh Tripathi join us from Premier. And what I will say is that as a public health research scientist, the more I learn about the microbiome, it has literally shifted the way that I think as a mom. It's shifted how I think about schools. It's shifted the way that I think about flu season or the way that I travel. I think about the personal products that we use in a house and the cleaners. And it really makes you question so much of what we've learned and so much cultural information that we take in and assume, right, that sort of we've understood this issue. And I really hope that everyone today realizes this is not just an issue for our buildings and the offices, for someone else like an industrial hygienist to understand, or a material scientist to understand, or a civil engineer to understand. It's a big challenge for all of us to make everyone in our community get this, make it accessible because it is so personal. And for all of us who've lived through a pandemic, we have incredible work to do to create a more resilient, healthy, and thriving environment, and more research to be done. So thank you all for your time, your passion, and your commitment to this space. And we're only getting started. So thank you all so much.
Thanks,
Thank you, Whitney, for hosting us. It was a really good conversation.